Assalamualaikum and hi, my name is Trunnion and I will be explaining the introduction of our assignment. So, a bascule bridge is a form of movable bridge which can be raised or closed to allow waterborne traffic such as ship or yacht to pass. So, and a bascule bridge operates similarly to the lever on a fulcrum. The fulcrum, which is fitted into the bridge girder, is made up of a trunnion and a hub. So, to make the fulcrum of a bascule bridge, a long hollow steel shaft called the trunnion is shrink fit into the steel hub. But in 1995, the assembly process did not work well on one of the Florida bridges due to the trunnion become stuck before it could be fully inserted into the hub, that resulting the company had to purchase a new trunnion hub that cost hundreds of thousands of dollars with so much time that are lost due to the delay of the construction. So in this group project, the authentic problem chosen through the discussion among us is based on the variance temperature that is required for the trunnion to shrink for it to slide perfectly into the bridges girder by using the bisection and second method of numerical method, as the equation given is non-linear equation. Okay, so what we want to solve in this assignment? Michael is one of the designer for the new construction of bascule bridge, and he wants to make a fulcrum to the bridge. However, Michael has faced the problem in his design where he need to fit a hollow trunnion of outside diameter 12.363 inches in a hub in a diameter of 12.358 inches. His plan is to put the trunnion in a dry ice/alcohol mixture. Temperature of the fluid is dry ice alcohol mixture is -108 degree Fahrenheit to contract the trunnion so that it can be slid through the hole of the hub. To slide the trunnion without sticking, he has also specified a diametrical clearance of at least 0.01 inches between the trunnion and the hub. To calculate the contraction of in the diameter of the trunnion, the thermal expansion coefficient at the room temperature is used. In that case, the reduction d theta in the outer diameter of the trunnion by is this. So, according to this calculation, immersing the steel trunnion in a dry ice or alcohol combination resulting in the necessary shrinkage of 0.015 inches despite his prediction of 0.01504 inches. However, as shown in this figure, the thermal expansion coefficient of steel decline with temperature and is not constant over the temperature range through which the trunnion passes. As a result, the first equation overestimates the thermal contraction. This was the error that he found in the calculation for the failure of the bridge. The diameter contraction for the trunnion, for which the thermal expansion coefficient changes with temperature, is given by this. If the coefficient of thermal expansion is considered to remain constant, equation 2 simplifies to equation 1. A second order polynomial is used to approximate the thermal expansion coefficient of a typical cast steel in figure 3, and so we got to the final equation, which is this. So, our group will solve this nonlinear equation using the second and bisection method to find the minimum fluid temperature needed to cool down the trunnion and get the desired contraction. The reason we want to solve it is because in order to avoid the construction failure to happen where the trunnion was stuck and cannot slide through the hub after contracting it, as it can cause material damage to the construction of the bridge that can affect the bridge durability and performance. Furthermore, In order to avoid of any accident from happening to any worker that involved in the construction of the bridge, the accurate process of measurement and assembling must be made as a safety precaution. So, by solving this problem, the construction of the bridges can going smoothly without having to spend any additional cost to repair or ordering any machine or material for the bridges, and the duration of the construction also can be reduced without any delay. The actual problem or real data utilized in this project is based on the internet sources and was obtained from these sources. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Salwa Farahani binti Muhammad, matric number CE190163. I'm gonna present our methodology 2.1. What is the suitable method to solve the problem? Through our problem that we had discussed earlier about Trunnion need to be slid in through a hub after expanding, this equation shows the temperature of the trunnion. We had discussed to use two methods, which bisection method and secant method. In numerical methods, which we expect it will be suitable to solve the problem. Next, how to solve it. The problem can be solved using several ways. As for our project is we had solved it using manually and using Microsoft Excel. Microsoft Excel can be used because it had the function that can calculate all the formulas and equations. After solving the problem, using both manually and simulation using Microsoft Excel, the comparison between both ways is important as we need to get the same value to make it correct and accurate. How to analyze and discuss the methods. As we have learned in class, the formula of bisection method is, and for secant method is, we had analyzed the method also using this block diagram and flowchart.
My name is Muhammad Aziz Azwan bin Muhammad Nordin. Today I will be explain about part 3, which is our simulation, our finding and why we get this finding. Okay, for the manual calculation, this is our equation, and what we need to do is use our desired value, which is A and B, negative 150 and negative 100. For step 1, we need to set our calculator to 4 decimal places, and using the formula for step 2, CI equal to AI plus BI divided by 2, and this is our step 2. For I equal to 0, what we get is negative 125. Negative 150 plus negative 100 divided by 2, and the answer is negative 125. Okay, using the same step, we need to find the iteration of 9 until 9. So, the answer we will get is negative 128.76. This is iteration. This is the answer, the value that we need. Okay, next, for the secant method, we use the same value, A and B. By using the formula for the secant method, what we will get is negative 0.0013. After substitute all the value that we desired into the equation. Okay, after complete the secant method, the answer is same as bisection method, which is negative 128.75. That is for manual calculation, and we will proceed to simulation. For the simulation, okay, for the bisection method, we decided to use Microsoft Excel to make a comparison between manual and simulation, manual calculation and simulation. Okay, firstly, what we need to do is to find what is A and B. As we can see here, our A is negative 150 and B is negative 100. What we need to do next is to find C. By using the formula in Excel, we can find C here. For FA, FC and FB, we need to substitute the value here inside the formula. For example, FA, FC and FB. Next, we need to complete it and find our desired value, which is negative 128.75977. This is for the bisection method. For secant method, what we need to do is find A and B also. For example, A is negative 150 and B is negative 100. So, using the formula again, just substitute the value here into the formula, and the answer we will get is negative 128.7548. Okay, next, what is our finding? We need to find the relationship between temperature and instant thermal expansion. The equation that shows the relationship between temperature and instant thermal expansion has been simplified. This is our equation, and temperature had a non-linear output and valid for a limited range which is at least 0.01 degree. In order to find the roots of this equation, we need to find TF at least negative 128.75. We can compare the result by using manual and simulation calculation for its speed. Lastly, why we get this finding? The significant figure is the reason for discrepancy between the result obtained by human computation and software. The calculator we are using today has a limitation in that because it can only display 9 bits of data. After all, the result obtained, we conclude that the final value we get is negative 128.75. Different result was obtained by using manual calculation and software, but the difference is acceptable. By using software calculation and formulation, we can obtain the result faster.
From this group project, I am able to understand more about the bisection and secant method by analyzing the engineering problem that we have picked and finding the right equation in order to proceed in starting to calculate the bisection and secant method. Okay, next my part in this assignment is making the introduction for this assignment. So I always have a great teammate that I can help me to understand and correcting any mistake that I made in this assignment. Lastly, in this assignment also, we can gain a lot of knowledge that somehow makes us keep thinking out of the box in order to finding the main problem and solving it, as not all real problem is similar to the textbook. Okay, that's all for me. Thank you. Bye.
For reflection and contribution to the group, when completing this assignment, I have learned a lot of new things in this course, Engineering Mathematics 4. Firstly, I tried to understand the article that we want to proceed with our assignment and help to create it into our own problem. Then, apply everything that I have learned in class about nonlinear equation. My groupmate and I discussed to use the two methods, which are bisection and secant, as the method to solve the problem. I need as my part, I need to do the method part, which a little bit tricky for me. I need to relate the problem that we have created with the two methods and write the report properly. Then I examine one by one of the steps for both manual and simulation to create a block diagram to do the flowchart. Throughout the preparation of this assignment, I have learned so many things, especially the attitude of cooperating with each other in completing the task successfully. I also need to do the manual calculation. When completing the manual calculation, I am able to master and better understand on how to work in problem solving by using bisection method and secant method.
Okay, for reflection and contribution in the group, based on our project, I learned how bisection and secant method works. Also, I found how to obtain the answer by using simulation on Microsoft Excel. With the guidance of Dr. Hodawati, I able to apply the bisection and secant method to find the equation. Other than that, I also can sharpen my calculation skill on this chapter. For this assignment, there is a lot of knowledge that I gained. I had a special communication between us as a group, and luckily everyone take their part very well.